we move to our last speaker, definitely not the least, because he is a well-sought speaker for the past weeks, months regarding COVID. So our last speaker is Dr. Jomar Fajardo Rabajante. He is a professor and UP scientist at the Institute of Mathematical Sciences and Physics, University of the Philippines, Los Baños. He holds an appointment as junior associate at the Quantitative Life Sciences Group, the Abdul Salam International Center for Theoretical Physics in Trieste, Italy. He is also the chair of the Diploma in Mathematics teaching program at the Faculty of Education of UP Open University. Dr. Rabajante is one of the Asian science diplomats and, as I have mentioned earlier, a well-sought resources speaker on the trends of COVID-19. Dr. Rabajante?
Thank you very much, Ma'am Nina. Good morning to those who are in this parallel session of PAASE. Thank you very much for inviting me here. Okay, so my talk is about one of our works, actually with Dr. Servantia, and probably this is somehow a continuation of what Dr. Servantia told us this morning. Okay, so my talk is about pollinator diversity and density measures, and some survey and indexing standards that we are proposing to detect and assess pollinator deficits. And this is in collaboration with the UPLB Biomathematics Initiative and the UPLB program. Actually, before I went to mathematical epidemiology, I'm already one of the drones, or probably one of the bees of our queen bee, Dr. Servantia. Okay, most of the results that I'm going to show you this morning are presented in our paper published just this year, modeling Earth systems and environment, especially the mathematical background of our methods. To give you an overview why we did this kind of research, because there are several things that we need to address, especially in pollination biology, specifically in Asia. And in 2016, in Science magazine, there are several scientists recommending 10 policies for pollinators. And the ninth bullet there is saying that we need to develop long-term monitoring of pollinators, and not just the pollinators, but also the pollination itself. Despite the importance of pollinators to agriculture and to the economy, sadly, the data regarding pollinators and pollination in the Philippines and the whole Asian region has been limited. And one of the reasons is that we don't have a standardized or harmonized method in surveying the diversity and abundance of pollinator species, including native bee species such as the stingless bees. And the use of widely varying survey methods could lead to difficulty in comparing the temporal and spatial status of pollination in Asian countries. So one example is, can we answer this question? Is there a decline of pollinators in Asia? And to answer this question is very difficult, because we cannot compare the results coming from different methods. Specifically, the methods are assuming different assumptions, and often it's very difficult to compare the numbers. And FAO established the International Pollination Initiative. Unfortunately, the only regions included here are from Europe, North America, Latin America, Africa, and Oceania only. And we are envisioning in partnership with the Association of bee practitioners in Asia, we are envisioning that to have a research initiative as a similar initiative for the ASEAN region. And this could help in narrowing the knowledge gap on global pollination. And if we are going to focus on the methods used, there is actually no universal pollinator diversity and density measure that can comprehensively describe all pollinator ecosystems. And with our study, we actually surveyed, and we have seen that common indices available in the literature do not consider species interaction, such as plant-pollinator interaction. And with that, we derived a new index that is compatible to our proposed survey method to monitor changes in pollinator deficits that I'm going to somehow show you later briefly, which considers plant-pollinator interaction. We call this new index as the P2P index. Okay, just to give you a brief overview of the survey method, and then later on, I'm going to show you the P2P index. The first step, we have actually 3 steps here in our proposed survey method. The first step is planning. And with the planning, we can start first by hearing the opinions of experts or practitioners in a certain pollinator hotspot. It's very important to have this first part of the planning for us to have a clear picture of what really happened historically and during the present situation in the locality. And in our survey method, we have actually considered 2 types of location. The first one is for the orchard or agro-ecosystem, and the second one is for natural vegetation. And with the ranking of pollinator hotspots, we also need to consider the seasonality of flowers and the area. And if let's say the expert would consider a certain place as class A, class B, or class C, it depends on the likelihood of having high number of flowers and pollinators. The survey expert opinion is just a starting point, but the next steps will be more statistical in the sense that we need to consider 2-stage sampling and mapping of each hotspot. If you have some experts working with GIS, that will be good. And the first stage will be randomly selecting hotspots, and in our calculator and our template calculator, we have already included this sampling calculator. And then the second stage is after selecting the hotspots in one locality, we need to randomly select 100 square meter sites to be surveyed. And this is for orchard and agro-ecosystem. We can have this, or we can have this setting. So these are some of the examples that we have surveyed with our team from the UPLBB program. And for natural vegetation, the method will be quite different in the sense that we need to find possible nesting sites of pollinators. And then after finding the different pollinator nesting sites, we randomly select nesting sites based on the calculator that we have included in the template that I'm going to show you later. Okay, and then after that, during also the planning stage, we conduct initial observation of the sample sites to answer questions such as how many flowers a pollinator species can visit in a day. This is just to get the visitation rate. What is the possibility of a species to be a pollinator of a plant species? So we need to consider the plant-pollinator matching. And this initial observation will be used in the preparation or training of the persons who will do this survey. And then the step 2 is the actual survey. For the actual survey for orchards and agro-ecosystem, we have 2 options. So the first one is as shown in this slide, we count the number of flowers and their visiting pollinators. We record the numbers per species of flowers and species of pollinator. And we can also have this setup. The idea here is definitely the setups will be different, but the idea is we need to have an equivalent protocol equivalent to at least 300 sweeps per 100 square meter site using a sweep net. For natural vegetation, the nesting site of the pollinator will be the center. And of course, the survey period should be during the antithesis as discussed by Dr. Servancia. And if there are other nests within the 250 meter radius, the counts will be corrected mathematically. We can also use a mathematical extrapolation for distances greater than 250 meters. So these are some of the pictures that we took during one of our survey observations in Calamba, Laguna. Okay, these are some of the pictures. And the step 3 is more on the assessment and the computation of the indices. And we created a Microsoft Excel template. We use Microsoft Excel so that this is very common to software to most of us. So we use this so that many of the researchers can use our calculator. From the template, we have there the sample size calculator, and also we have there included the different diversity measures. We have modified Shannon index for pollinators and modified Shannon index for flowers. But the original derivation that we have included in the template is our P2P ratio and index. The P2P ratio and index is to measure the pollination matching. And the threshold there is 1. If we have less than 1, means few pollinators, there are few pollinators compared to the plants or compared to the flowers. And the idea of the P2P ratio and index is based on pollination networks. This is because with the idea, this is coming from the idea that there are certain species of pollinators that are best suitable for certain plants, specific, probably because of their body size and because of their foraging behavior. The first computation is the P2P ratio for a pollinator species in a specific survey period, and this value is a function of the abundance of the pollinator species, okay, the visitation rate of the pollinator species, and the flower assignment value, where the flower assignment value is, as shown in the screen, is the summation of the possibility value of being a pollinator of plant species I and number of flowers of plant species I. So there is, in the template, you need to input values in a certain matrix and the normalization factor. Okay, and then after computing for a certain survey period for a specific pollinator species, we can compute the P2P index for as an aggregate of the different pollinator species in a specific survey period. And the formula is shown here also in the slide. Take note that there are two values here. The P2P ratio is computed for each pollinator species, while P2P index is the aggregate measure for all pollinators. And from the in the Microsoft template, we have also included there the increase, decrease measure, like the geometric mean with respect to a reference survey period to measure change in time. Let's say we've started doing the survey 5 years ago, so we need to use our method from that time up to the future, so that we will have a harmonized method through the years, and we can compare the temporal changes in the pollinator dynamics. And there's also the summary of indices, whether local or national. So just to show you what are the values that can be inputted in the Excel file. So you have here the pollinator abundance and the plant abundance. And of course, these are, I'm showing you the template, but in the template, we have also included there the somehow researcher non-mathematical friendly results. But this is just to show you what's inside the template. And this template already automatically calculates everything for you after inputting the values that needed to be input, the needed input. Okay, just to briefly show you some of the examples, we surveyed one site in Calamba for an ampalaya farm. And as you can see from the screen, the ampalaya fruit is not that good in terms of the aesthetic. And one of the reasons is there's a lack of pollination. And this is one of the reasons is when we went to that survey site, we only saw 2 roaming carpenter bees and approximately 20 cabbage butterflies and flies. But there are 48,000 flowers in 400 rows. This is a 2-hectare ampalaya farm. And when we computed the modified Shannon index, it's less than 1, means of course there's a low diversity of pollinator. And the carpenter bee visitation is 15 minutes interval per row, which means the carpenter bee might be too stressed working with the work of as a pollinator. And the P2P ratio is less than 1, actually near 0, which means that there are few pollinators compared to the inflorescence. And as I said, there are 48,000 flowers and approximately 28,000 fruits. And we asked the owner of the farm about the timing of the pesticide application. She said they apply pesticide during the morning. And there's another site, a cucumber farm, also not too far from that ampalaya farm. But what we have found is a totally different story. There are approximately 600 Apis cerana bees and other pollinators. There are 48,000 flowers in 30 rows. This farm is smaller than the previous farm, but the story is totally different. There are many bees around. When we computed the P2P ratio, the value is 1.5, greater than 1. Not high, but still greater than 1, which means that there are enough number of pollinators for available inflorescence. And they have many fruits. And we asked what's the reason. I mean, we just asked that the farmer what time they apply pesticides. They said they still apply pesticide, but in the afternoon. So because of that very slight difference in the behavior of the farmer, the resulting diversity and abundance of pollinator are very different. And we have also other activities, mango farm in Pangasinan, and one of possible reasons for the difference in the stories of the 2 farms in Calamba is because of the schedule and location of pesticide application. And Dr. Servancia has already highlighted this during her presentation this morning. And just to give you a brief background, we also did study on the foraging behavior of pollinators using mathematical methods. And we just don't use mathematical methods. We also ask our applied mathematics students to also do some of the actual observation using this type of experimental design. So so that they will have some idea about how to implement the simulations and models. And these are just some examples. And we did this type of experimental designs. And yes, from the result, there are specific foraging behavior that we can somehow see patterns, and probably we can use this for further optimization of the use of bees for crop pollination. Okay, and we want to acknowledge our sponsors, the ABAR, UPLB, and CropLife Asia, and of course the UPL Biomat and the UPL BB program. Thank you very much.
Thank you so much, Dr. Rabajante. So that is our last speaker.